functions. This, that, this. Instead of seeing functions this way, there's a fun way I'll show you to look at them. And I'll show you how this way ties in closely with the function you just saw. To start off from now on, I want you to imagine a function not as a collection of letters or a collection of numbers, but as a machine. To spice things up, think of our machine as having magical powers. And just so you know, I'll call our machine a ball adder. The ball adder can process only balls. It can't process other things like food, stones, paper. You get the point. Now that we know what the ball adder can do and what it cannot do, let's talk about how it works. The ball adder operates in a way such that if we give the ball adder one ball, it will give us 2 balls. If we give the ball adder 2 balls, it will give us 4 balls. If we give the ball adder 3 balls, it will give us 6 balls. At this time, I want you to think of what enters the machine as input and what goes out of the machine as output. From what we've seen so far, we can say the output to expect from the machine is 2 times the input we give it. Now let's say we get another ball adder, but with this one, we can pick how the output will change based on its input. If we can tweak that, let's say we want the output to be equal to the input squared. If we give our new ball adder 1 ball, it will give us 1 ball. If we give our new ball adder 2 balls, it will give us. At this point, you will probably have noticed something. Every ball adder machine shows a relationship between the output and the input. This relationship is simply a rule that tells us how each input is treated before it becomes an output. Loosely speaking, this is what a function is. A rule that gives out a unique output for each unique input. The rule for the first function is that the number of balls at the output should be equal to double the number of balls at the input. The rule for the second function is that for every ball, the resulting output should be the square of the total number of inputs. Now, talking about machines, if we input the wrong thing into a machine, it will damage the machine. The question is, how do you know the inputs that will damage the machine? Well, like I said in the beginning of this video, for a ball adder in particular, we only input balls into the machine. Anything else breaks the machine. If we would have different machines like food adder, money adder, or stone adder, by the same logic we used for the ball adder, this machine should be able to alter the number of foods, money, or stone that we give them. Anything else would damage the machine. In the same way, every type of function or machine has a unique set of inputs that we can input into it. And since we are talking about keeping the machine in good shape, we can decide to keep track of the good inputs for the ball adder machine. So if we collect all the possible inputs we can put into a machine and pack them into a list, we call this list the domain of the function. The domain is simply a collection of inputs that keeps our function working fine. And also, if we decide to pack the outputs that we get from a certain good inputs into our machine into a list, we call this list the range of the function. Now, let's quickly relate all of this to regular write-ups that you see in math texts and in your classroom. In classrooms, the input, because it is an unknown number, is always referred to as x. The output is always referred to as f of x, and it is written like this. This is how a simple function looks like. It tells us that for every x input, we'll get an output of 3 times x. Remember what I said earlier about machines breaking down for the wrong inputs? In this situation, wrong inputs just mean the values of x for which the function is undefined. But how do we even know when a function is undefined? For illustration purposes, here is a simple polynomial function and a simple rational function. The polynomial function can take any value of x. This means that if we decide to put any number into this function, there will be an output. In other words, it never breaks. Suppose we decide to write out its domain, we'll have a collection of all real numbers. The rational function is quite different, given that it has a numerator and a denominator. The denominator is the main point of interest. It can be any number apart from 0. And so that means that the rational function that we have on the screen can take almost any value except 0. So that the set of all good inputs for this rational function is all real numbers apart from 0. Hence, we can say the domain of this function is all real numbers minus 0. So to end things, I like to say, just like we have different machines with different restrictions, other function types also have personal restrictions that affect their domain and their range. That's it. To learn more about domains of functions, I'll leave a link to my tutorial video. If you like the video, subscribe to the channel. I'll be making more content like this, and I also make tutorial content too. So if there's anything you don't understand or you want to learn, you can leave a comment. I'll make a video for you as soon as possible. Don't forget to leave a thumbs up. Don't forget to leave a comment on what you think about this video. Don't forget to share with your friends who you think will find this video helpful. Thanks for watching.